Yeah, I've seen several examples of me refactoring code in this course. But one thing I forgot to tell you earlier is that refactoring is a creative process. So if we give the same code to two different developers, they will refactor it differently. Even the same person might refactor the same code in different ways at different times. So don't take what I've shown you so far as the ultimate or best way to refactor code. These are just some ideas. Now in this video, we're going to work on a few different ideas. These are the ideas that I came up with just before recording this video. So what I'm going to show you might look very neat and clean because I already practiced this before recording this video. So that's one thing. The other thing is that once we come up with a working solution, before we refactor our code, we should have a bunch of automated tests. Now, automated testing is a completely different topic. It's beyond the scope of this course. I have a course on automated testing with C#, but not one with Java at the time of recording this. But the idea of automated testing is to write code to test our code. So if I refactor this code without having a bunch of automated tests, it is possible that I might break the solution along the way. That is why we need automated tests. So every time we make a change, we run our tests, and our tests will tell us if we have broken anything or not. With all this introduction, now let's jump in and see how we can refactor this code. So when I was looking at these two methods, get and remove, I saw a lot of similarity. In both these methods, we're trying to find an entry. The only difference is that in the remove method, we simply remove that entry, but in the get method, we update the value of that entry. So this is an opportunity for refactoring. We can create a method called getEntry and reuse it in both these methods. Let's see. So I'm going to create a private method that returns an entry object, getEntry. And here we get a key. Now, once again, we should use our hash function to find the index. And then we need to go to the bucket at this index. So bucket equals entries of index. Now, if bucket is null, that means obviously we don't have this entry. So if it's null, we're going to return null. Otherwise, we're going to iterate over this bucket. Look at each entry. If we find an entry with the same key, we're going to return it. So for var entry in bucket, if entry.key equals this key, we're going to return it immediately. Otherwise, we're going to return null at the end. Now, this code is a bit ugly because we are returning null in two places. We can solve this problem by reversing this Boolean expression. So instead of saying if bucket is null, we're going to say if bucket is not null. Then we're going to have our for loop. And at the end, if the bucket is null or we don't have an entry with this key in the bucket, we're going to return null. So this is cleaner. Now let's reuse this method in our get and remove methods. So forget about what we're doing here. Let's just comment it out. This code is ugly. What is the algorithm for removing an entry? First, we should find that entry. So we call getEntry, give it this key, and store it here. Now, if this entry is null, we're going to throw an exception because we didn't find it. If entry is null, we're going to throw a new illegal state exception. Otherwise, we're going to remove it. But how are we going to remove it? We need to find the bucket. So once again, we're going to have these two lines. We're going to calculate the hash and then go to entries of index. I would like to extract this concept in a separate private method called getBucket. So just like we have getEntry, we're going to have getBucket. Private linked list of entry. GetBucket for this key. Here I'm going to copy these two lines over here and finally return the bucket. Now these variables make our code more readable, more meaningful, but this logic is really simple and we don't need to express it in 3 lines. We can simply return entries of hash of key. In my opinion, this is very self-explanatory. We don't need these extra variables. So let's remove these lines. Now we can reuse this new method over here because here we're trying to find the bucket. So I'm going to remove this index variable. We don't really need it. And here I'm going to call getBucket and give it this key. That is better. Now back to our remove method. So if entry is null, we're going to throw an exception. Otherwise, we're going to remove it from its bucket. So here we call get bucket of this key and then remove this entry. Simple as that. 4 lines of code. As opposed to, how many lines do we have here? Perhaps 10 lines or more. So let's delete all these. And here's our new remove method. Let's apply the same technique on the get method. So forget about what we're doing here. What should we do in this method? We should find an entry and return its value. So we call get entry, give it this key, store it here. Now, if entry is null, we're going to return null. Otherwise, we're going to return entry.value, right? Now, we can rewrite these lines using the ternary operator. So we're going to return something. We start with a condition. Entry equals null. Now, if this condition is true, we're going to return null. Otherwise, we're going to return entry.value. This is cleaner than this implementation. So let's delete these and also remove this commented code. Beautiful. We're almost done. Now, what about the put method? This is an interesting one. Over these 2 lines, we're trying to locate the bucket. If the bucket is null, we're going to set it to a new linked list. So here we can call get bucket and give it this key. This will give us this bucket. However, if bucket is null and we set bucket to a new linked list, this is not going to initialize that cell in the array. It's only going to initialize this variable, this local variable. So here we really need this index. Now, is there a better way to achieve the same thing? Well, what if we change the get bucket method such that if the bucket is null, it will automatically create it? No, we shouldn't do that because this is violation of a principle called command query separation. So our methods or functions should either be queries, they should either return answers, or they should be commands, which means they can change the state. If we change the implementation of this method such that it automatically creates a new bucket, this method is going to have a side effect, and methods with side effect are not good. Having said that, we can create another method called get or create bucket. The name of this method is going to clearly tell us that if the bucket doesn't exist, it's going to create it. So there is a subtle but important difference. So let's go back down to the bottom. I like to put all my private methods at the end because they're all implementation detail. So we have get bucket. Right after that, I would like to add get or create bucket. So once again, we're going to return a linked list of entry and call it get or create bucket. We give it this key. Now here we need to get the index. So we call the hash function. Then we look up the bucket, entries of index. If bucket is null, we're going to set entries of index to a new linked list. And finally, we're going to return the bucket. Also, I would like to add a vertical white space before my return statements. Now back to our put method. So we're going to delete these lines. That was just for explaining some concept. Here's the actual implementation. Over these 3 lines, we are trying to get or create a bucket. So let's call our new method get or create bucket for this key. And we store the result here. Now we don't need this line. That's better. So now we have a bucket. We're iterating over this bucket and comparing the key of every entry with this key. This logic looks familiar, doesn't it? This is our get entry method. So I'm going to replace these 3 lines with a call to get entry for this key. Now, if we have this entry, we're going to update its value and return. So if entry is not null, we're going to set entry.value to this new value and then return. Otherwise, we're going to add this to our bucket. So we call bucket.add a new entry with this key value pair. As simple as that. Now let's delete all this code over here. There is just one tiny problem in this code. This code has ADD, or attention deficit disorder, because here we're talking about one story, then we forget about it, we go talk about a different story, and then we come back to our original story, which was around buckets. So our code is not focused. It jumps all over the place. We don't want code like that. So we can solve this problem by bringing this line down where we use it. So first, we try to look up that entry. If we have it, we'll update it. Otherwise, we'll get the bucket and add this entry to it. Now, technically, we don't need this bucket variable because we have used it in a single place. So we can replace it with a call to get or create bucket like this. There you go. So this is the final implementation. Now, I've done a lot of big changes here. I don't know if I've broken anything or not. Hopefully I haven't. But this is where automated testing comes to the rescue. If I had a bunch of automated tests around this hash table class, I could run hundreds of tests in less than a second. And they would tell me if I've broken any functionality or not. I don't have to come back to the main class and keep testing this class manually with different values. This is the benefit of automated testing.